Hey, what's up guys? My name is Dustin. Today we're going to talk about something that I've been needing to make a video on for a few months now. I haven't really made many technology stuff in the past couple months, and this is long overdue. We're going to talk about my laser cutter. So for those of you who have watched my channel for a good while or have watched some of my live streams, you probably know that I got myself a laser cutter. A number of months back I went to Folger Tech. If you want to see that video, it's right here. And of course at Folger Tech he's got a whole bunch of laser cutters, and that's what they used to use to cut the melamine and the plexiglass or whatever, the acrylic, all that kind of stuff. They don't really use them all that much now because of the introduction of ACM material in the printer kits. So while I was up there talking to John Folger himself and Chris Minchin, who admins the Folger Tech Facebook group, I was, really into lasers, and lasers are cool and all that kind of stuff. So when I got back down to Florida, I went on to eBay, did a little doopity on eBay, and found myself one of those standard Chinese K40 laser cutters. They're not that expensive. I got mine for I think $320 shipped to my house. It came with the water pump. It came with the actual, obviously the laser itself, the exhaust pump, the hose for that, and all that kind of stuff. Everything you need to get it fired up. Now for those of you who are into lasers or into the K40 lasers, you'll know that they're not that good out of the box. The control board that it uses is not really that great. You have to use a little USB dongle thing in your computer at all times in order to connect to their software, which is proprietary. You can't really do a whole lot of nonsense. You can't really do grayscale or anything. You can do dithering and kind of emulate grayscale, but it's not really grayscale. So after playing with the stock laser for a little while, I decided, you know what, I'm going to modify it and all that kind of stuff, and put some cool control boards in there and just go to town and modify it and making it my own. So that's what I'm going to talk about today, and show you my laser, the stuff I've done to it, the mods I have done, plan to do, and a couple, my workflow on how to get the laser to go from here's a picture to here it is on a piece of wood or whatever material. So that's basically the story. Let's go look at my laser. I'm over here now by my desk once again. So in the background, this is the current setup that I have for my laser workflow, I guess you could say. So laser's obviously here, computer's up here, and they're connected via USB. I'll get more into that after I show you the actual laser, but just for reference, this is the setup that they exist in. And my main computer is obviously right there. So my window right there, because exhaust is necessary. So welcome to my laser cutter. Obviously K40 laser, standard red nonsense, but the case is really the only thing that's left that is stock on this laser. I've done a whole bunch of modifications to it, and I will show you those now. So case itself, pretty standard, it's the standard layout. The exhaust I have back there, it's pretty standard as well. I have sealed it off better. I used some cork around the edges of the actual plastic housing to make it seal to the back of the laser a little bit better. I've also added tape and stuff, so there's not very much leakage. When this thing's running, even if it's cutting wood, does not make any sort of smell or anything in the room, which is awesome. That hose is going through here behind the FT5R2 and going out the window. I don't have the little thing I put in the window right now just because it's cold outside and it's hot as hell in here, so I'm trying to let some air in. But normally I will use this piece of foam board in the window, and this little hole right here is where the little hose goes. Now the first thing you might notice if you're looking at this is this little control board here. This control board is completely custom. I obviously didn't like the original control board, and I wanted to add some switches and stuff, so that is why there's a custom control board. This is not the first iteration of this, and it will not be the last, and I'll tell you why. So obviously the first thing you see here is this touchscreen. This is a TFT32 MKS touchscreen. I don't really like it. I don't use it. It's not even connected right now. I will be remaking this control board without it because it's not very good. It doesn't work for what I wanted it to work for. I wanted to do wireless lasering using one of those. I need to turn off my phone. And this it doesn't really work. It works, but it's not as quick as I want it to be, so I'm not using it. So this I'm not using. It is a cool touchscreen. It's just I'm not using it. The next thing is going to be the output current control, or not control, but the gauge. This tells you in milliamps the output current of the actual laser tube, and you have the dial for adjusting that right here. You can adjust the current in the software, and I'll show you that when I show you the control board. But this is like basically the max current, and then in the software you can limit it from there. So I might have it on 25 here, which is, I don't know, about 10 milliamps here, which if you limit it to 50% there, then it might be 5 milliamps, and so on and so forth. So there's a number of different, you can use this a number of different ways. I have these little guides right here. I use 14% on that knob for rasters. I use 35% on here for cuts. That basically will just limit the maximum current to whatever it is. I think 35 is 15 milliamp and 14 is about 5 milliamp, more or less. So these are just references for me on this scale. That's not going to really match anything if you have your own, but that's besides the point. This is just for me. Over here I've added a switch for the air assist, which I will show you in a minute, and also the water pump and exhaust. Some people have the water pump and exhaust on two separate switches. I only had two switches, so I just combined them because I figure if your water pump's running, you're probably going to want the exhaust running as well, so I don't see a problem with having it only on one switch. The laser power and laser test, these are the original switches that came with the laser in the first place. This is a water temp meter. It shows you the water temperature in Celsius for the water reservoir, which I'll show you in a second. And this is main power. So main power on, that turns the power on, and this shows you the water temperature. So right now the reservoir, the bucket of water, is at 12.5 Celsius and going down because there's a bunch of ice in there. If I turn on the water pump and exhaust, now the water pump down here is now running. It needs to be running because I still have air in the system. I haven't run it yet. And also this exhaust in the back is now running and venting out into the atmosphere outside, which is great. As you can hear just right now, this machine's really not that loud, even when it's not cutting. The thing that is loud is the air assist, but everything else is fairly quiet. I can run this machine at night and it doesn't really bother anybody. It's not that loud even with the air assist. So while we're here, I might as well show you. This is just a standard 5-gallon bucket that I filled up with water. This is just tap water. Most people will tell you should run, deionized water or purified water of some sort, but I empty out the bucket after every time I, use the laser in a day. So I'm not reusing the water like most people would. So I don't really see an issue with using tap water, and I haven't had any growth issues or anything like that. So with this setup, the water pump, the original water pump is running down into here. You have two bottles of ice, basically. I'll take a bottle of water. Those are, I think, 1-gallon juice bottles or something like that. That goes into the freezer. Once it's frozen, just put it in here into a bucket of water, and this keeps the laser down at the temperature it needs to be. For my laser, I run it at least below 19 degrees Celsius. 19 degrees Celsius is the maximum that I will run. You get longer life in your laser tube if you keep it under 20 C, so I try to go between 10 and 15 Celsius is where I usually run my laser at and where I want it to be. So I just remove and put in frozen bottles basically to keep the water regulated. There's one of those wires, the black wires, is the water pump, obviously, and I also have the temperature probe down in there right by the outlet, or the inlet of the water pump, which is going to that temperature gauge right there. So everything is right here. I used to have a different setup to where this was underneath the desk and it ran through the back of the desk, but I wanted to make it easier to get to and everything, so I have this setup, which is a temporary kind of setup to where once I'm done I can just pull everything out, put it on a towel, and then take the bucket out of here. Makes it a little nicer. So this back here might be a little bit difficult to show you, but back here I have wired in an outlet. That's basically, both of those outlets are wired. One is this one right here is the air assist, and that one over there is the air pump / water pump. So these are two separate outlets, or two separate outlets which are connected to those two switches that I showed you before. So basically, if I switch on the air assist, it puts power to that outlet, powers the air assist. This one over here powers the water pump and exhaust. Over here, I have added fittings for the water. These are coming out, these are sealed, it's not leaking, everything's great and handy basically. So that is just running underneath the laser over to the tube, and on the inside I have water or hoses running from nipples in there up to the laser tube itself. I have changed out the wire or the hose from the standard surgical tubing that they give you. It was starting to get all nasty and it was corroding away with something, I don't really know. So now I'm using some, I believe it's poly tubing or something like that. I don't know what it is. It's just some cheap tubing I got from Lowe's. And it seems to be working really well. I also have, as you can see, the black wire right here. That is the temperature gauge going from the LCD on the control panel down into the tube, into the bucket. And this tube right here is going over to the air assist. This is an air assist pump that I got off of, I think, Amazon for, I don't know, maybe 20 bucks or something like that. I have it supported via these springs, so it's not actually touching anything, which really reduces the noise. And obviously this is a pump, it's not the quietest thing in the world, but suspending it like this to where it's not touching anything hard really helps with the vibration and the noise when it's on. I'll just give you a little example. Air assist on, and it off. It's really not that loud. The loudest part of having that on is hearing it come out of the nozzle in there, which is what I'll get to next. So for those of you who have seen these types of lasers before, this will be a little bit different for you. So obviously, first thing you'll notice, this is not the standard grate. This is a grate I got from somewhere, and it's just a 12 by 12 grate. It just makes it easier for the laser to cut. You're not getting burn marks underneath because the burn in the laser and everything is going through instead of hitting a hard surface like a metal surface and then trying to, bouncing back up into the wood and all that. So it's better to have a grate material. You'll notice these are magnets that I have right here. This grate is set to basically, if I put in a 1/2 inch piece of wood, the surface will be at the right focal distance for the laser. That way I can basically laser different thicknesses. All I have to do is put these little magnets in here, and I have a bunch of different ones in here, different thicknesses. I just stack them on top of each other for different thicknesses of material I want to laser or engrave. And of course, there's calculations you're supposed to do for all this stuff. It's pretty close. It's good enough for me. This isn't a like in-depth how to get the perfect laser, quality or anything like that. I'm just showing you my setup. In here, this is not, it's kind of janky, but these are 2020 beams that I stole from one of my Folgertech printers. It's actually the CNC attachment for the FD5. I stole it from that. So that's what these are. These are very jankily held in. As you can see, I got things bent over and holding it in place, and it's holding it at a certain height. It's all sorts of nonsense. But it works, and that's my main thing. I'm going to turn off the water pump for right now. The next thing is, this is the air outlet, basically. This is where the pump, the air exhaust pump, is sucking in air to go outside. This normally comes out to like somewhere like here or something like that, stock. So I just cut it badly with some like needle nose pliers, like peeling it open like a can opener because I didn't want to take a Dremel in here. It was late one night, I got nothing else to do. So this is way out of the way. This is, it's further up than what the laser can cut, so it's fine where it is, and I'm happy with that. I put this little piece of 2020 in here. When it's up against this, it is at the furthest X0, basically. So this is basically like the edge of the cutting area, so that's why this is here. Not really necessary, but I had it laying around, that's why I put it there. So obviously another thing is, this is the stock nozzle or stock, whatever the hell these are called, hot end, or you know what I mean. It's that thing. What isn't stock is the air assist thing. This is a 3D printed, adapter that attaches to this hose, just attaches directly on here, and it, you know, it adds air assist to one of these. There are these, how are they called? Nozzles or something? I don't know. There are air assist versions, which I do have, but I don't have a lens for it, and I've ordered 3 from 2 different sellers on Amazon, and they all sent me the wrong one. All of them. So I said, screw it, I'm using the stock one, and I'm just going to 3D print a air assist attachment, call it a day. And that's basically what I did. And it works fine. So I've been using this setup pretty much since I've had the laser a number of months now. Works fine. You know, this stays out of the way, doesn't get in the way of anything, and the air assist is an absolute must if you have one of these. You cannot cut, you know, wood without it, without catching things on fire. So an air assist is a must. Like I said, this hose just runs out the back, goes over to the air assist pump over there. And it's as simple as that, really. So this is the money shot. This is the reason why this laser works really well. Like I said before, the stock control board is not very good. It does work, especially if you're using the new K40 Whisperer software, which someone made. You can use the stock stuff and it's a lot better, but it's still proprietary software on there. You can't modify it, you know, blah, blah, blah. You need to have weird software. I wanted to be able to use whatever software I wanted, using whatever files I wanted. So I changed out the control board. I actually have the control board right here. This is the original, whatever the heck control board that they give you. It's not great, but it works. But I wanted better. So inside here is a lot of wiring. This is the underside of the control board that I made. You know, that's standard wiring. And here I have a 12-volt power supply. That is powering the control board right here. That's the laser power supply. And the control board is an MKS S-Base. So MKS S-Base, a lot of people might know that as a 3D printing control board, which obviously you can use it as one. But it is a Smoothieware capable control board, and it does work pretty well for this application. There are a number of guides online of people showing you how to wire up one of these, and you know how to make it work. You have to basically use the PWM control of like a fan or the bed circuit to control the power supply, the laser power supply, and it's kind of weird how it works. I have 2 power supplies because I didn't want to overload the 40-watt laser power supply, and it's kind of complex, but it does work. And it does work pretty well, because using this thing, I can run a regular G-code. I'm using Smoothieware, so I can connect it to LaserWeb or any other lasering software, G-code running software, and it actually works pretty well. You obviously do have to do your own kind of custom wiring and everything, but it does work, and I'm pretty satisfied with using this. This board actually is kind of screwed. Like, it's got a couple blown components on it, like the LCD panel over here. The LCD panel pins do not work. The USB, if I plug in the USB to my computer while the power supply is on, it'll catch the damn USB cable on fire. I'm sure some of you have heard about that with MKS boards. Some MKS boards with like 3D printers. I don't know why it happens, but it does. So yeah, that's a thing. So if I use a laptop, it doesn't happen, which is why I use my laptop to run this thing. So yeah, that's basically the setup. MKS S-Base board running Smoothieware, set to all the laser settings and everything. If you guys want me to make a video tutorial on how to hook this thing up and how to get Smoothieware on here, let me know in the comments. You know, be like, hey, I want to know how to do this, and I can definitely, you know, make a video. There's a number of good guides online, but there's a lot of, you know, various informations out there, and sorting all through it to make it work with yours is kind of difficult, but this does work, and it's a way better upgrade. You know, you can do micro-stepping and everything on this compared to the original board, and it's just better overall. You can do PWM control with the laser, so you can do grayscale. You just get a better quality, you know, laser overall, which is great. Obviously, the rest of the wiring in here is all for the, you know, the switches and everything, the water pump, all that nonsense. You know, there's various different things in here going on, but for the most part, that's basically it. And it does work pretty well. I gotta do a little bit of setup before I can actually laser something on here, but I'm gonna turn on the water pump so I can get that filtered up through, get the pipe, the actual laser tube nice and cool. And I'm also gonna go and install that window thing over there. So I'm gonna go do that, and then I'm gonna show you how I actually set up workflow for lasering stuff. So give me a minute, I'll be right back. Alrighty, so I have the laser hooked up to the computer up here, and I have this little air thing blowing out. Like I said, there's a good seal around that, so none of the fumes come in here, which is a good thing because fumes suck. Also, in case you're wondering, I hooked up this little switch in here to a LED light. Makes everything so much easier to see. That's a really good thing. So anyway, the workflow for doing this. Obviously I have everything on. I have the water pump running, getting the thing cool. So if I am making something custom or I need to do some editing to a certain picture for whatever it is, I'll do it on my main computer, because I have on my main computer I have Photoshop, I have Adobe Illustrator, all that kind of stuff. My computer's more powerful, so I'll do photo editing in that computer. I'll then put it either on a flash drive or put it on a home group, something like that, send it to my laptop. This laptop is running Linux Mint, and I'm doing that because the Linux drivers for USB seem to be better than Windows, so that when I'm doing a raster, which is a lot of lines of code all at once, it can send it better via USB. For whatever reason, if you're using just a regular Windows laptop, it doesn't always work and it doesn't run as fast. You'll get a lot of stuttering and it doesn't really work very well. That is especially true if you're using LaserWeb on the computer to make the G-code, and using Smoothieware, which has its own optimization protocol basically. LaserWeb also has an optimization thing, and they kind of fight over each other, which is not good. So if you're trying to stream via LaserWeb through USB to that thing on Windows, it's not good at all. But the way that I have it set up now, it actually works really well. So I'm going to show you that. So obviously I really should be using a screen capture software, but I don't have any on this computer, and I'm just doing this as a basic overview kind of thing. So let's see what I can find in here. So when it comes to downloads, here's a basic photo. Sure, this will work just fine. So this is some family portrait thing I put in here. I don't really know. I'm just gonna also make the size a little bit smaller. In the X direction I can do up to 300, and I'm also gonna make it zeroed in both directions. Actually, I'll make that at a 5, so it's pretty close to being the dead center for that picture. So there's a number of different ways you can photo edit. If you just put this photo in there just like it is, it's not going to be very good. You're supposed to take this into a photo editor, do some filters onto it, make it black and white, make it look good. I'm just showing you what my workflow is to actually do this. So then, of course, in LaserWeb you can drag this over to here. If I was doing a raster, it's already on raster. I pick the settings that I'm using. I usually, for a raster, will do a cut rate of 150. So I'm going to just put that in. 150 millimeters per second. I turn off burn white. And for this example, because it's not going to be very good, I'm going to turn on dithering, which is basically it's not going to really do any grayscale. It'll just be dither. And then I'm just going to hit generate. Like I said, this is kind of my basic workflow. I'm not actually trying to raster this image right here. It's not going to look good if I do. But if you guys want to see a tutorial on how I actually edit photos to do laser cutting, let me know. So obviously I like doing stuff on my computer because it's a lot more powerful. But as you can see here, this has made G-code out of it. Where you see green, that's just a travel move, and where you see red, that is an actual laser. And if you look really close, you can see how this is dithered. You can see how those are a series of dots. Yeah, there you go, right there. You can see how it's a series of dots. Dithering does look pretty good when you, do it. I like to do it, especially for complex photos like this. This obviously looks like crap because I didn't photo edit the video. I can't stress that enough. Don't just put regular photos in there and then expect them to look good, because they will not look good. Say this is what I wanted and everything was fine. I'd go over here and this exports the G-code, and I export the G-code to in here, whatever. I'll just name it something.gcode. Now what I do is I go into Repetier Host. Yes, Repetier Host, for those of you who are into 3D printing, you know Repetier Host is a 3D printing, basically a 3D printing software. I have it set up in here to be the exact size of the laser cutter. Now I do this because, for whatever reason, LaserWeb, its G-code streaming is not very good, like I said before. Whereas Repetier Host, its G-code streaming is actually pretty good. So I'll just go over here and connect to this laser cutter, and it'll connect just like it would with a 3D printer. And I will load in the G-code. So that family jot G-code is right here. It doesn't show you really a preview or anything like that unless I add the travel moves. That's like the basic shape it's going to be doing. And it says 21 minutes. This is actually pretty accurate, which I like. And of course, I can do manual control. So the cool thing is I can home the laser. If I go in here, hit home. It homes it just like it should. So more or less, I'm using Repetier Host like I would with a 3D printer, and I'm running the G-code on it because all it's doing is just sending G-code to the Smoothieware board, and it does its thing. And that's basically all that I got to do. So when I get to the point to where the temperatures are good, I have the wood in there how I want it, I would just hit print, and it will start running the G-code like it would if it was a 3D printer, and it works absolutely great. The biggest thing, like I said, if I'm using LaserWeb, I set it to 150 millimeters per second for the raster. It'll run like 70 maybe if I'm using LaserWeb. It'll just stutter and it doesn't run very fast. If I'm using Repetier Host, it runs at the speed it's supposed to run and everything works great. Also, I should mention what I do when it comes to putting wood in here. I've been using this Luan board. I get this at Lowe's at work. And I use it because, for whatever reason, it burns really well. It doesn't burn away. Some softer woods, it won't actually burn and become black. It'll just kind of, just incinerate the top layer and go down, and it's almost like you're burning into the wood, but it doesn't actually burn the wood. So you'll have like a textured cut almost, but it doesn't leave any sort of dark, so it doesn't look good. Whereas this seems to not actually burn through, it just burns and darkens, which is really nice. So whenever I want to put it in here, I just set it in here. Obviously these magnets are in here to space it up, so the surface right here, because I'm engraving, the surface I want to be at the focal length, which in this lens is 50.8 millimeter or whatever it is. So I just center it right in here, up against here, and down here it's right lined up with this little L bracket. And that is 0, 0 over here, and it knows the rest of it is all the area. One thing I'll do if the board is kind of warped and it's wobbling, I'll take one of these little magnets over here and just place it over here. I'll try to get it in a corner where there's not going to be any lasering, which I know this corner and that corner there won't be any lasering, so just set them over there, and I'll move that around if I need to, and that prevents the thing from wobbling around a little bit or vibrating, or if, like I said, the board's warped, it'll keep the board down as it should be. And like I said, I'll just go and I'll hit the button and it'll start cutting, and it'll be great. In fact, I'll even show you that. Obviously you want to keep this closed when the laser is going because, lasers are dangerous. I go over here, I do have the laser power button off right now. I'm going to depress it. If I wanted to test the laser, I could test. The current is already set at about 15, which is what I use for raster. And I'm going to turn on the air assist. Like I said earlier, I already homed the laser. So I'm just going to hit print. And it should start moving. It's going to home again because I have it set to do that in the G-code. Now, obviously you can see I have the board a little bit higher up than it's supposed to be. That's going to happen. I'm going to turn off the laser power so it's not just burning into nothing. And when it gets into range of the wood, I'll turn it back on so you can see what it does. So like I said, I'm not going into super high detail as to the settings I'm using to make all this happen when it comes to video or photo editing, and also my LaserWeb settings. If you guys want to see a video about that, let me know and I'll make one, because I'm sure there's a lot of people out there who would love to see that kind of stuff. So I think this is finally on the wood. Turn on the laser, and as you can see now, it's actually cutting, or not cutting, but engraving. So this will continue to go back and forth. Like I said, this is supposed to be 150 millimeters a second, which is pretty close to what it's actually running. This whole board I'm cutting to 8 inches, or 8 inches by 12 inches. So this is about 300 millimeter run, and it's doing it in almost 2 seconds. So it's about 150 millimeters a second. So this will continue to do this cut right here, or this engrave all the way up, and make it look pretty cool. Now, conveniently, I happen to have already done this engrave, you know, on an actually photo editing it and making it look a little bit better. And this is how it turned out. Like I said, when I made the laser web thing, this is using dithering. This is not using grayscale, so it doesn't look as good as it could. If I was using grayscale, or letting it do grayscale, it would look a little bit better. There'd be a lot more variety. But I made the photo for dithering, which has a lot of detail, and it kind of gives it a cool look. This obviously isn't the best quality it could be, but this is just kind of throwing it together really quick. But I think this looks pretty good, so eventually this will look something similar to this. Probably not exactly, because this is a different G-code file. But yeah, this looks pretty good, doesn't it? I think it looks pretty good. I just turned it off because it's loud. Obviously, I didn't go really into detail as to what I do to actually set up the files and everything. If I wanted to cut something out, I'd have the shape in there, and through LaserWeb, I would, you know, have to pick different types of files in order to do cuts, and I would change different settings for all that. But, you know, this is just a basic overview as to what my workflow is to make things occur. So, yeah, that's basically what it is. I think I've talked about everything from the water that's in there, the laser, the control board, everything that I have going on. Smoothieware is pretty darn good, even up to the computer that I'm using, Linux, using LaserWeb and Repetier host through USB. And yeah, you get things like that, which actually look pretty darn good. Like I said, this isn't the best thing ever, but it does look pretty good for what it is, for just throwing it together really quickly, you know. So yeah, that's more or less my laser right now. So I probably look really sweaty. I have my room fan off right now, and it's really freaking hot. It's like 82 degrees in here. We don't have the AC on, and it's cold outside, but my window's shut because I was doing stuff with the laser. So yeah, I'm going to open my window now so I'm not going to die of, you know, whatever the heck it is. But hopefully you guys enjoyed that video about my laser, super basic overview. If there's anything you guys want to know, any questions or anything like that, let me know, and I will make, I don't know, I'll either comment to you, or if there's enough demand, I'll make videos about my actual process as to settings I use for LaserWeb, you know, anything like that. But I think this whole setup does work pretty well, especially for me, for doing it in my bedroom. You know, I am in my bedroom, and so I can cut wood, I can cut acrylic, and I don't smell anything, which is really good, because you really don't want to smell acrylic when it's being cut. It smells bad. So I hope you guys enjoyed this video. Like I said, any questions, comments, concerns, go ahead and put them in the comments, and I will definitely respond to you, or I'll try to at least. More videos to come. I appreciate you guys for any support and all the support that you give me. And yeah, like I said, anything, let me know. And until the next video, whatever that might be, I'll see y'all later.